Okay, welcome everyone to the last session of the day. We are going to talk about Flyway over the next 30 minutes. So we're going to have a rather busy schedule, so I'm not going to lose too much time about telling you who I am. I've been doing lots of talks the last couple of years about continuous delivery at a number of conferences. It's been my general area of interest, and born out of that interest, Flyway was created about 3 years ago, but we'll talk a bit more to that in a while. And I'm currently working on a different product, which is called Photon, which will let you basically grab an application and turn it into a whole virtual machine that you can deploy at once. But enough about me. Let's have a look at our session today. So as I said, we have a lot of ground to cover over the next 30 minutes. So I would ask you, if you have any questions, please hold them until the end. So we can be sure to get all the way through. And if people want to leave, that's fine. And I'll be around later. We'll have plenty of time to answer them at the end. So the plan for today is going through a number of steps. We'll start by looking at the general problem area, database migration tools in general, try to solve. We will then have a look at Flyway, at how it addresses these problems. We'll have a quick demo, and then we'll look at some more advanced scenarios to finish up. Okay, so here we have a standard example, which is just some regular business application where we have a couple of fields that we would like to enter information in, and this information has to be persisted in a database. So for this database, we just have a simple table, an account table, 2 columns, very easy, and all is well until someday our business requirements change and we have to add a third field. So what has to happen? Our relational database has been tailored for a particular structure, so this structure now has to be adapted to be able to fit this third field as well. How do we do that? Well, when our world looks like this, with just one application and one database, it's actually very easy. All we have to do is just enter some statement, and it will transform the database in the way it should be. However, most of the time, we don't actually live in this nice and easy world. It looks more like this, where we have a large number of databases, and they all have to be kept in sync to make sure the code will actually work with what we have deployed there. And so that's a much tougher nut to crack. If you actually look at this picture, on any regular environment, you have a surprisingly large number of databases. So just on a 5-developer team, where each developer has 2 databases, one for unit tests and one for running the actual application. And if you add a CI server onto that, a test server and the production machine, that's 13 databases already that have to be kept in sync. So it's really a tough problem that needs some care. The first answer that's really been provided to that has been, well, we don't do manual statements anymore. We just group them together in some update files, and then we can run them through the command line with some utility that comes through our database, and then we have a deterministic way to get from point A to point B. That's already much better, but we still have a number of problems left. The first one is, well, we have our database delta files, we have our database itself, and then comes the question, in which state is my database? What has already been run there? Which objects are already present? Which objects are still missing? How do I know which changes still need to be applied? Not only that, once I know exactly in which state my database is, I may have multiple update files available locally. How do I know in which order to execute them? Because it doesn't help me if I try to rename a column if I haven't actually created the table yet in which it is supposed to live. So, once we look at the whole picture here, we see that all these problems are really something where you need a good set of tools to take care of. So the first guys that really had a comprehensive answer to this question were the Rails guys, and just about 10 years ago now already, with Rails migrations. When I had a first look into this, which was somewhere in 2010, I couldn't find any solution that met my needs on the JVM, and that's why I started Flyway, just about that, 3.5 years ago, into 2010, and it's actually hit at least a nerve with a certain part of the community, because it's gotten 60,000 downloads this year alone, so it's not just a small hobby thing anymore. There's actually a lot of people that find it useful. But why do they find it useful? Well, what Flyway really does, at the end of the day, is it helps you go from a certain state of your database to the next one. So how does it do that? It has a special table that will add to your database, where it will keep track of every single change you make. So in this case, when we start from an empty database, it will start by creating an empty table, which by default is called schema version. You can change it to whatever you would like, but this is the default. And once it finds an update script to take you to version 1, it will then execute this update script, and you will see all the objects being added to your database, as well as a row to this special table. So you see here there is a row where it will say that it's found version 1, it's automatically found the description for that version, and it's a SQL type migration, and it ran successfully in 546 milliseconds. Once it finds the next update, in this case version 2, once again it will apply the SQL statements you've given it, and it will add another row to the schema version table, which then makes it very easy for Flyway to query this table and find out at which, how far we've gotten, in which state the database is. So, what were the key goals in designing the framework? The first one is, I wanted to be able to enable cooperation between the developers and the DBA, so that you would speak a common language and you would be able to leverage both set of skills. That's why I thought SQL had to be a central part of the solution. The next part kind of builds up on this. If you make an expensive investment into some powerful database system, you should be able to use all the features of it should you require it, and not be stuck to the lowest common denominator between this database and all the other databases the tool happens to support. The third one is, if you like the tool, you're more than welcome to use it, but if for some reason, at some point in the future, it doesn't meet your needs anymore, you should be able to move on. So I've tried to reduce the lock-in to the absolute minimum. And the next thing is, if you put it in, it should really just work out of the box, and then you should be able to forget about the tool itself. Just drop new update scripts in whatever directory you've configured, and that should be the end of it. And all this really results in something else, which we'll touch a bit more at the end of the session as well, which really ties into the whole continuous delivery mindset, where you have a very reliable way to roll out your software, and in this case also the database, which results in decent working hours for everyone, where no one has to come into the office on a Saturday night or at 5 in the morning. We'll see what we can do to help that. Okay, so one of the basic premises of the tool should be it just works. You should have a fantastic out-of-the-box experience. Once you download it, you should be up and running within minutes. How is this achieved? It's basically by sticking to the basic principle of having to say no to certain features and really stick to a strong core. Another way to achieve that was to reduce everything you have to set up just to get it working. So everything is based on conventions as far as possible, which you can configure if they don't suit you, but that's definitely something that makes it a lot easier to get started with. It also has 0 required dependencies besides the JDK itself and whatever JDBC driver you happen to require for your database, so it doesn't pollute your class path with all kinds of stuff you don't need. And it still, to this day, after 3.5 years, revolves around just 6 basic commands. Info, which lets you query both the database and what you have available locally, so that you can see what has already been applied, which changes have been performed, and which ones are still waiting to be applied. The next one, migrate, performs the migration itself. And clean is a very useful one, certainly for development, where you can point Flyway at the database, and it will get rid of all the objects within it, so that you can have a fresh start from there. Then we start validate, which allows you to check if what you've applied still matches what you have locally, so you can detect if somebody made some changes to some scripts that have already been applied. Init we'll talk a bit more about later, and repair as well. It's more of a niche use case. So the tool supports most of the popular database systems. I think these are the 9 or the 10 most popular ones, so you'll probably find the one you use on this list. And you can run it in a variety of ways as well. So how is it built internally? What does the architecture of Flyway really look like? Well, everything is centered around an API, just with these 6 basic methods and a couple of getters and setters. Behind this API sits a migration resolver. The migration resolver lets you basically look at what you have locally, find all the files that might contain updates, sort them by version, and just basically get a good view of what's available. Once you have that, and you know what's in the database, you should be able to actually execute these things. So that's where the executor comes in. We've already seen it. We have a metadata table for bookkeeping, so we have to be able to manage that and deal with that. And then finally, there's all the little quirks and everything that gets abstracted away for dealing with specific database systems is stuck in some corner there as well. On top of this API, you can either build your own Java applications, which we'll call Flyway directly, ideally on startup. We'll go into a bit more detail later on. You then have a Maven plugin and tasks. You have a command line tool if you don't want any build tool installed on your server, for example. And now, since a few months, there is a Gradle plugin as well. What do you have to do to run it? At its core, it's just this, 3 lines. You new up the central Flyway facade. It's just the one-stop shop. That's the one class you deal with. It automatically has defaults for the directories where it will look on your class path. It has defaults for the name of the table in the database, so that's all you have to do. You point it at a data source, which can be either a data source object or just 3 parameters. In this case, your JDBC URL, the user, and the password for accessing your database, and you go migrate. That's all you have to do. Same thing for Maven. It's very analog, so you see all the names are identical of the different parameters, so it's just URL, user, password. The same for Ant, the same for the command line, and the same for Gradle. So it's very easy to move from one client to the next. Okay. So we've seen in the beginning that you usually on a project, even with a limited number of developers, have a very large number of database instances over all your systems. And these have to be kept in sync because your code will make certain assumptions. Once your code starts up, and for example, your Hibernate session factory will start trying to map entities to tables so that you can read and write from them, it will assume that certain columns are present, that certain tables are present. So the life cycle of your database is really tightly coupled to the life cycle of your code. So, how does it normally work on a lot of projects? Is the code will access the database, and then comes a database update script for the next version, which updates the database, and then the new code can access it. So really, because the life cycle is so tightly coupled, there's actually no way these should actually be deployed separately. They belong really together, because one can't work without the other. So the best way to eliminate any potential error of forgetting to apply an update is having these updates run when your application starts. How does it look like? We've got our databases in both our development and, in this example, our production environment. And we have a deployable which contains both our code and the database delta scripts. Once we start the application, we want to migrate on startup. So we Flyway finds whichever files are available locally, whichever migrations are there, looks at the metadata table in the database, sees there is a difference, and applies the different scripts to bring it up to date so that all the objects are there we need, and then the Hibernate session factory, for example, can start. And so it's very nice if you have all this together, because then you can just throw it at some other system. It doesn't really matter in which version the database is, because the database could have been at version 6 in development, and you have scripts to migrate to version 7, so it would just migrate one version. Your production might still be at version 4. And now you bring all these scripts in. It looks, okay, well, my database is at version 4. I've got scripts up to version 7. So when the application starts, Flyway sees, okay, I need to upgrade to version 5, 6, and 7. And then I'm done, and then JPA can start. So all this looks good and well, except that in practice, it often breaks down due to one big problem, which I call the fear of DDL. There is this strange industry misconception in a lot of minds that somehow once you see DDL, boom, it all seems very dangerous, and you end up with this. You can throw 10,000 lines of new code into production, nobody cares. But if you put in 3 lines of SQL, ooh, they're dangerous. They need to be reviewed. Now, why is that? Well, it turns out, as I said, that we have this image where create, read, update is this innocent little thing, and as soon as you have an alter table, it gets super dangerous, and you have to be very careful. But nothing could be further from the truth. Let's go back to an example here. We have a table where we have some bank accounts, where we have the bank account holder, and we have the balance on the bank account. Now, bad luck, we've applied an update statement, but we made a mistake in our where clause, and all the balances have been zeroed out. Now, for me, this means actually the exact same thing as this. Either I have a very good backup, or I can close my shop. As soon as you have the possibility to modify data, you have the possibility to destroy it. And so from a business perspective, the risk is identical. So let's have a quick look. We'll just make a brief demo. We don't have a lot of time, but we'll have a brief demo at what it actually looks like. So I have a small demo project here where I have a Maven POM where I've integrated Flyway. So I've got H2 here on board as well. I've got the core jar for Flyway, and I've got the Flyway Maven plugin. They're configured so that they access the local H2 database, which is empty at this point in time. We will switch to the console, and here we can have a look with Maven, Flyway. So you remember the 6 commands, Flyway info, which will then have a look locally, see if it finds any migrations, doesn't find any, has a look at the database, kind of prints the results. So let's go back to our project now, and I have some database migrations here, which I'll just drag into my little class directory here for the demo. So I'm dragging the first one in, and let's have a look again. So I have to run compile as well to make sure it gets copied over to the target folder, and we run Flyway info. There we go. So it now found one migration, which is pending. Now let's have a look at this migration file in our IDE. Here it is. It's just a very simple one. So you see I've highlighted here. That's because the name is a bit small in the tab, but that's the name of the file. And so it found out, the file is v1_person_table.sql, contains a simple statement. And if we look here at the output, you see that it automatically, based on the convention, extracted the correct version number 1 and the description as well, and marked it as pending. So if we now migrate the database, we can do Flyway migrate for that. So here we are. We've seen that we have successfully created the metadata table, schema version. We found that the version of the schema is still an empty schema. we then found one migration and applied it successfully in 139 milliseconds. So if we call Flyway info again, we can now see that the migration has been successfully applied. I will now copy 2 other migration files in there. And I'll now run from Java. So what we have here is, again, the simple way to call Flyway. So we just new up the Flyway facade and give it a data source and call migrate. By default, it looks in a class-bound package called db.migration, which we have here, where we have our 3 files. So one should already be applied, and it should find 2 new ones, which should then run. So let's have a look at what this guy does. Okay, IntelliJ didn't build, so we'll get it to rebuild this quickly and copy it over. Sorry about that. So get it to pick up these guys. And let's have a look. Let's give it another second. I don't know why it's taking this long. Okay, give it another 5 seconds. If it doesn't work, well, it's still hanging for some reason, maybe the network. I'll do it from the command line. Okay, let's just do it here. So, Flyway compile, Maven compile, Flyway migrate. So there we go. It found that the first version, that the existing version of the schema was 1, and it found now our 2 new files, sorted them correctly, and applied 1.1, and then version 2, so it successfully applied 2 migrations. If we now look at Flyway info, we see that all of them are gone. We can now do a Flyway clean as well, just to get back to an empty database. And our database is empty again. Sorry about the IntelliJ thing. Here, it finally ran through. No idea. Okay. Okay. Okay, so let's now look at some more advanced usage scenarios, because this was pretty basic. So what we have now, the first thing that often happens is if you run within a cluster environment, you will have multiple nodes that might start at the same time. So how do you deal with that? Well, Flyway applies careful locking when applying all the migrations. So every migration runs within a transaction, and it acquires an exclusive lock on the schema version table, so that whichever node arrives first will get to apply the updates. The other ones will wait, and will see the fully migrated database once the lock is released. Another very common scenario is when you actually hit the limits of SQL. Because SQL is very practical for text-based data, it kind of works well, but once you get into more complicated things, and the first one here is once you get into blobs, into large binary objects, it just doesn't do it anymore. If you have to manipulate an image, rotate it, or do something, it just doesn't work with SQL anymore. The second thing where SQL is not very good at is advanced text processing or data processing. So in this case, if we've got a bunch of phone numbers in unformatted format and we want to pass them into a specific format, maybe it's doable with SQL, but it's kind of hard. So Flyway comes in there with another alternative, which are called Java migrations. So what it is really just a simple interface, JDBC migration, that has to be implemented, which contains a single method, migrate, which passes you a connection. You are then free to perform whatever operation you would like with this connection. So in this case here, we create a new prepared statement and execute it, but you're free to do whatever you want with it. Now, the next thing is, most of the projects are in greenfield. You actually have some baggage, you already have a database out there that you can't just throw away and start fresh. So how do you deal with a production environment? So in our case here, we have a development test production environment. What do? The first thing is we take a dump of the production environment. So we dump whatever structure of the tables we want to have managed by Flyway and whatever reference data we want Flyway to manage. Once the dump has been performed, we call Flyway init on the production database. What this does is it creates the metadata table and will tag the database as being in a certain version. So it adds a special row to this table that says you're in version 5. Once that's done, we assume, in this example, I assume that we can't discard the data in our test database either, because testers have built up valuable test cases there and haven't gotten an automated way to recreate it. So we have to manually align the databases to make sure that the structure and the reference data we want managed by Flyway is absolutely identical. It's the last manual operation we have to do. We then called clean on the development database, so it's totally empty. And we call migrate with Flyway, and we pass it the dump. Flyway is able to pass proprietary formats, so that's not a problem. If you use MySQL dump, for example, it knows about all the special constructs is there, or about Oracle packages and more advanced types of database-specific dialects. It's not a problem, so it will migrate the database, and we now see that all 3 databases are at the exact same level, so that when version 2 comes along, we can just apply it equally to all of them with no changes. So, now another important thing is writing your migration so that they can be backwards compatible with the last version of the code actually deployed in production. So we have very little time. I'll just quickly go over this. But the advantage of that is that if you use this and you roll out a new version of the code and it doesn't work, your database might have been migrated, but the old version is still able to work with the database at any time, so that you don't have an issue there of having to restore backups and all kinds of things if that doesn't work anymore. So it's really always a 3-step process where you have the old code accessing the old database, then the new code accesses the new database, migrates it, but in a way that the old code can still read it. Once you discard the old code, you are able to roll out another version which will get rid of whatever compatibility structures you've put in place for that. So we'll very quickly go over this. How does it work? If I want to rename a column from surname to last name, I have my little table here, first name, last name. I come with a new version of the software that expects last name to be there. The old one still expects surname. So the traditional solution of issuing an alter table doesn't work anymore. I can't use that. So what do I have to do instead? I will first add an extra column. I will copy all the data over. I will create a trigger to capture whatever new data gets entered there. And once I have all that, both versions of the code can work correctly. If the old version gets discarded, if we've updated all the instances and everything works well, then we can then roll out another version of the code which will then carry a database migration with it that will remove these compatibility structures. So in this case, it will remove our compatibility trigger, it will remove the old column, and we are left with just a new solution. So it's a 3-step process that allows you to be a lot more relaxed about all that when rolling it out if you stick to it. And it's actually a lot of standard recipes, and they're available in this book here, which it's a bit old. It's about 10 years old, but it's still very current. And so you don't need to reinvent the wheel when you want to look up how to solve something like that. You just look it up, and they have all the steps nicely detailed in there. What does the future hold for Flyway? Well, in GitHub, there is already support for SBT that's been checked in. We're just reviewing it to make sure it's current for 0.13, and then we'll get it out. And then there's going to be Android and SQLite support coming soon, and then next year, a web framework support so that it integrates well in the workflow of these frameworks. So here's the website for Flyway. Have a look at there. It's on the website. There's a comparison matrix as well between Flyway and the different other tools in the JVM space that solve this problem. So I think the message I want to leave you with is that you should at least use a tool to do this. Use the simplest possible tool to solve your problem. Whether it's Flyway or another one doesn't actually matter. I think the main message is use a tool to tackle this complicated problem. It's available on GitHub, and that's all I have for today. So thank you very much. We're out of time, but thank you. Do we have time to take questions or not? No answer? Anyway, I have some Flyway stickers here to hand out as well at the front. Feel free to help yourself, and I'll be around for questions as well. We're out of time, so if people want to leave, they're more than welcome to leave. Otherwise, I'll be here to answer questions as well. Thank you.